We are going to learn something today, I tell you what. Okay, you've never seen this video before anywhere else. Nobody has. I call this video removing the poo between your ears. Don't worry, it's nothing against you. Everybody has it. What we have here is a 2" by 1" incredibly powerful neodymium iron boron. On top of that is the most diamagnetic element that exists in the universe, bismuth. 99.9% pure. It's cast by me. You'll see here we have a little nipple right in the middle there, so it's able to act like a top as it's spinning on top of the magnet as I twist it. Now here we have an extremely high Gauss, huge, I've got it taped to the plate, huge neodymium iron boron. So we have enormous magnetism here, and we have enormous supposed anti-magnetism here, right? Well, this is bismuth. It's just a hair shy of 100% pure, so when I do this, it should want to roll right off of that magnet. Even more, that little tiny nub is right at the edge. If you actually know it's in the center, you notice it didn't fly off. It's sitting right there at the edge of the magnet, just like balancing a needle on a needle. So, why isn't the universe's most diamagnetic element, bismuth, in its pure form, as I cast it, sitting on top of the strongest permanent magnet field that exists? Actually, you can get a couple Gauss larger, but it won't make any difference. So why does that happen? Well, bismuth is extremely diamagnetic, so that means it's repelled by magnetism. Well, look at where it stopped. Right there at the little nub is where it stopped. So, can you look at that for a second? Why is the world's most diamagnetic, i.e. anti-magnetic, object sitting at a hairline on the edge there and stopped? Why? Well, let's tilt our camera up a little bit more. You just have to think. Nobody thinks. The world is full of descriptions and no explanations. The reason is looking you square in the face. Both of these objects are composed of atoms. Well, yes, we know that. So, what's the difference? Super diamagnetic, i.e. the bismuth, means it is extremely dielectric. It is anti-magnetic. It has very low magnetic permeability. But whether it's the neodymium iron boron and the hexagonal lattice structure of this neo, which has been charged up from cap banks and discharged increased dielectric capacitance, or it's this bismuth, it's hard to say that word, isn't it, bismuth, whether it's this natural pure bismuth, which has been refined to near 100% purity, inside the inner atomic of both, whether it's the neodymium, the iron, the boron, or the bismuth, you have dielectricity and you have magnetism. That's why this bismuth disk will not fly off the neo if I actually spin it wrong or too fast. I mean, it will, obviously. So, why did it stop there? If you could actually look underneath, you will see that tiny little fine nub sitting right on the edge of the neodymium. Now, what do we understand about magnetism? Strong Gauss field, centrifugal divergent magnetism here, centripetal, convergent here. Extremely strong dielectric capacitance in this neodymium iron boron, coherent as it was charged and created. Well, what's the similarity between these two? Well, here we have an extremely powerful magnetic field emanating centrifugally, divergently from the large neodymium. And here we have the universe's most diamagnetic object. Hates magnetism. Nothing hates magnetism more than bismuth, right? Well, doesn't matter whether it's the bismuth, the iron, or the charged neodymium. Inside the two, dielectricity always goes towards dielectricity. Over here to our left, you can't see it, I've got a little levitation device that I'm scaling up in wire form. So you have a little magnet there floating between two bismuth discs that's being suspended by a larger magnet up above it to counteract gravity. But the point is, I mean, can you put two and two together? What is going on here? Nobody talks about this stuff. So, what's the point that I'm trying to get to you here? What are we to understand? This is the universe's most anti-magnetic object in its elemental form. Absolutely pure. Unless I fling it really hard or spin it in an oblong fashion, it will not come off this extremely powerful magnetic field. The reason why is because the bismuth, it fell off that time. You hit it just right, it will fly off. Simple mechanics, but 9 times out of 10 it will not. It'll ride right at the edge. If it hits that little nub perfectly, it will fall off. Gravity is gravity is gravity. Gravity is stronger because this stuff is right above lead. It is extremely heavy stuff, so that's simply a fact of gravity, not magnetic repulsion. But we have a perfect medium here between dielectricity and the centrifugal divergent magnetism. Yes, bismuth is diamagnetic. Yes, we know that. It is the most diamagnetic element in the universe. Here we have it in our pure form. Here we have an extremely large neodymium iron boron. Powerful, no less. So, why doesn't the bismuth fly off the magnet? Unless gravity catches it just right. It might this time. Most of the time it doesn't. Now there we got a perfect example. It is sitting on the hairline edge. Extremely heavy bismuth, right above lead. Lead's 208, bismuth is 209. Why is it not? See if I just give it a little nudge. It'll fall off. It was sitting right on the edge of that little nub where this acts like a top because of that little nubbin. Because the magnet, as every other element and the bismuth have in common, is that dielectricity goes to dielectricity. Right now, you'll see that it stops with the same amount of crescent. What you have here is a ratio of phi exposed on the magnet to 1 over phi to the power of negative 2, 0.381966. Every time, given a little variance, you'll see that that is what will be left. A remainder, you'll notice the same crescent shape. Phi to the power of negative 2, or 1 over phi to the power, 0.381966. Anyway, it's a ratio of phi to phi to the power of negative 2. Gyromagnetic precession angle is also the point of pressure gradient equalization between the superdiamagnetic bismuth and the strong centrifugal divergent magnetism of the neodymium iron boron. Remember, here we have, you notice right where it stops, right at the midpoint here? That's right, that is the point of centrifugal magnetism. That is reintegration, where magnetism reciprocates convergently, centripetally, back to dielectricity. Here we have an extreme dielectric object, which is diamagnetic. It has extremely low, the lowest elemental magnetic permeability. Here you have oil and water. Here you have, God and Satan. Bad analogy, but these are supposed to not come together. Why is the bismuth always resting on the edge unless gravity grabs it just perfectly? Why is it stopping right there? Look, you'll notice the same thing, a ratio of phi to 0.381966. My discovery, my mathematical premise that magnetism, dielectricity, in perfect harmony. Obviously there are a lot of variables. There is a specific geometry, and it is all related to the golden section. It is field incommensurability, or Fi. It is how pressure gradient mediations will work themselves out in perfect lowest pressure. Look, phi 0.381966, phi to the power of negative 2. So, let me spin it the other way. Doesn't make any difference which way I spin it. Hopefully it won't fall off due to gravity this time. I'm also shaking the table that it's on. Look, we end up with the same thing. Phi, this exposed area is phi, 1.618033, and our disk stops at the ratio of the large neo at a ratio of phi to the power of negative 2, 0.381966. In other words, this section right here that the bismuth disk is covering up is a ratio of 0.381966 to a ratio of phi. Remember, the magnet is not a magnet. What does that mean? There's no such thing as magnetic repulsion. We talked about that in other videos. It doesn't exist. There's only dielectric avoidance and counteravoidance. Yes, we have an extremely powerful divergent magnetic field around the periphery. It has a high Gauss reading. There's also a high Gauss reading at the center. This is a known fact. This isn't my premise. This is absolute empirical fact. So, remember, a magnet is not a magnet. It is a dielectric capacitance object with incommensurable magnetodielectricity operating in a special geometry of a double hyperbola of divergent and convergent magnetism, which is dielectricity and discharge. But here we have the most elemental diamagnetic object in the universe. But like both of these, they both have on the inner atomic dielectricity and magnetism. Doesn't matter. This is extremely dielectrically capacitant as it was charged. Here we have elemental, strong, dielectric, low magnetic permeability, what we call diamagnetic, and this is the most extreme diamagnetic element. All that means that it has extremely low magnetic permeability, but as you've seen time and time again, it will not spin off unless gravity grabs it just right and hits that little nub just perfectly, because gravity is gravity. It will not jump off the neodymium. Why? Because the bismuth, the high dielectric of the bismuth is attracted to the high dielectric of the neodymium iron boron. Yes, the bismuth is diamagnetic, but diamagnetic only applies to this on our magnet. Now this is a huge magnet. Normally a magnet obviously isn't this big, but this is what the bismuth is repelled against right here. What am I pointing at? I'm pointing at the centrifugal divergent high Gauss area of both sides of the quote-unquote magnet, which is dielectricity and discharge. That is divergent, centrifugal, dielectric discharge, as Faraday called it, the dielectric field. It is literally just the horse poop, the horse manure of dielectricity and discharge. That is what the bismuth is repelled against. The bismuth is attracted to the dielectric capacitance of this neodymium as it was created. Both of these have strong dielectric attraction. What? The world's most anti-magnetic material, bismuth, is attracted to this extremely powerful, quote-unquote, magnetic object? Yeah, well, it's not a magnetic object. It is a strong, coherent dielectric object with resultant macromagnetic effects emanating from around the circumference. Correct? Correct. We know that from other videos. So, the bismuth hates one part of this magnet and it loves the other part, in a really crude analogy. Hates this part, centrifugal divergent magnetism, that is why it's called diamagnetic. Loves this part right in the middle. Loves it. You notice this stops at the same place again? Phi. You actually see this crescent underneath it here? That's 0.381966. Phi to the power of negative 2. So, here you have oil and water. Here you have the beauty queen and the elephant man. Two things that never come together, and yet they are together. Why? Because it doesn't matter what it is at the atomic scale, it's all magnetism and dielectricity. This bismuth is extremely diamagnetic due to this centrifugal divergent dielectricity and discharge, i.e. magnetism. Okay? The horse manure of dielectric discharge. We've already shown you the dielectric inertial plane, how this magnet was created, whether it's a coherent dielectric object from magnetic induction or a dielectric capacitance increase. This is a dielectric object. Yes, as we stated in other videos, there's no such thing as magnetic attraction. Everything works by dielectric avoidance or counteravoidance. Magnetism attracts nothing. Nothing. Magnetism attracts nothing. It displaces things. Okay? Magnetism, just like any form of radiation, particle radiation or otherwise, does not attract anything. Name a radiation that attracts anything. It doesn't exist. Doesn't exist. Yes, I call this video getting the horse poo out between your ears because everybody has this issue. Well, that's bismuth, and we know you make levitation devices out of bismuth discs, but you know, it's bismuth hates magnetism. Well, a magnet isn't a magnet. What am I talking about? We've talked about that in other videos. A magnet is not a magnet. What does that mean? It is a dielectric object with resultant high discharge of divergent centrifugal magnetism. The discharge of dielectricity. This bismuth is as attracted to this magnet as if this were another magnet. It only expresses it differently. I've shown it to you how it expresses it. It will rest at a ratio of phi and 1 over phi. It is attracted, yes. So bismuth, the world's most diamagnetic element, is also super paramagnetic. What? Yes, that's right. Bismuth repulses this. Centrifugal divergent magnetism. The dielectricity in this bismuth, the same as any atom in the universe, is attracted to the dielectricity, extremely high dielectricity. You notice it rests right here? Right here? Look, that's the centripetal point. No matter how I spin it, unless I make a mess, and I spin it a little too cockeyed and it actually flies off due to gravity. The little nubbin underneath isn't absolutely perfect, but nevertheless, I've shown it to you several times. So look, think, use your brain, please. Use your brain. What do we have here? We have fire and ice, the beauty queen and the elephant man. We have evil and purity sitting in perfect harmony. Why? Because dielectricity is attracted to dielectricity. The only reason bismuth repels magnetism is the same reason quote-unquote like poles repel each other. Do you understand that? The same reason like poles repel each other is the same reason bismuth repels magnets. But it doesn't repel magnets. Magnet is a term, is a connotation. Well, we call this a magnet. It's not a magnet. It is a dielectrically coherent and increasing capacitance in this case, rather than simply coherent from magnetic induction. It is a dielectric object. There is no such thing as magnetic attraction or magnetic repulsion. Only a dielectric avoidance and dielectric counteravoidance. Magnetism is definitionally, connotatively, denotatively radiation. It is dielectricity in discharge. If you understand that, you'll understand so much more than everybody else out there about magnetism. What's going on? Just tell them, say, look, there's this idiot on YouTube. He's got an extremely powerful, huge neodymium iron boron magnet and the world's most diamagnetic element that always will combine in perfect harmony. Look, once again, we see phi to the power of -2. It always seems to be attracted at the central point for some reason. It stops right here. Oh my God, why does the bismuth stop right at the centripetal point? In other words, it doesn't go over here. It stops right here. Because bismuth has extremely high dielectricity. It is a diamagnetic. It is attracted to the dielectricity of the quote-unquote magnet here. That is why it is stopping here. Not here or over here if it could, but here, right here. The returning centripetal convergent magnetism, let's call it the portal to dielectricity. There's two portals to dielectricity, for lack of a better analogy, right now. Along the dielectric inertial plane and the centripetal point at the center of every magnet. If you have a Gauss meter, you'll notice you'll have extremely high Gauss readings along the edge of the magnet, intermediate zone, and also high, but not as high as the centrifugal point here. You have a divergent centrifugal vortex here, reciprocating to the other side, and if this were the other side, is returning centripetally here. That is why this bismuth disk is attracted to and repelled by this quote-unquote magnet. It's not flying off, it's sitting right on that tiny little nub. That little bitty nub. I mean, if this were repelled by the magnet, it would just keep flying off. But it doesn't. Because it is as attracted to this magnet as is another magnet. It expresses it differently, for lack of a better analogy, but dielectricity to dielectricity. It's an absolute. There are only 4 ether modalities in the universe. Dielectricity is number 1. Dielectricity and discharge is the second ether modality. The third ether modality is electricity, which is a combination of, we know, phi times psi, magnetism, and dielectricity equals electricity. In special galactic and stellar formations, dielectricity terminates as in the creation of nuclear particles. Protons are magnetically dominant, and neutrons are dielectrically dominant. Protons, you can get neutrons. Neutrons, you can get protons. The quantum nonsense calls it beta decay and inverse beta decay. So here you see the world's most anti-magnetic object is actually attracted to this extremely powerful magnet. It doesn't jump off of it. Its dielectricity wants to join and create the smallest counterspatial avoidance with the dielectricity, high dielectric capacitance in this neodymium iron boron as it was created from discharge coils. It is as attracted to the magnet as another magnet is. It doesn't express it the same way. They don't jump together extremely fast, but that's due to the fact of the magnetodielectric geometry within the quote-unquote magnet. It is different in the bismuth, but it wants to be as joined with the magnet as another magnet of equal size as this one does. It just expresses it differently because it does not have the same double hyperbola accretion disk. Everything within here is same dielectricity and magnetism in the inner atomic. It just expresses the quote-unquote attraction or dielectric avoidance differently. Here you keep seeing it at a ratio of phi and 1 over phi. Look! There are no tricks. There's nothing underneath here but a book. Let me see, is my magnetic levitation device still levitating? I made a little wire model. Before I end this video, I think I got my point through clearly enough. Let's see. Yes, this is very crude, but I only created it as a wireframe model to test some new materials. So here you see my bismuth discs, 2 of them, and just a very, very crude wireframe model to test some materials. But we have levitation, of course. Yes, very crude. Obviously, it's nothing professional, but it's only a test. So, now you understand. It's all magnetism and dielectricity. Magnetism is dielectricity and discharge. This supposed super anti-magnetic element bismuth is as attracted to this magnet as another magnet is. It only expresses it differently and obviously doesn't accelerate extremely fast, but it is as attracted. So why, over here, are we getting a magnet levitating between 2 bismuth disks? Well, because the bismuth disks are repelled not by this right here, but by this. This is what bismuth hates. This is what the bismuth is pushing away. Not this, this. That's right. You can see that on a Gauss meter too, okay? Intermediate zone. High Gauss reading here, extremely high. The highest right here. Not my opinion, this is hardcore empirical fact on this particular matter. Okay, we understand? This is what the bismuth doesn't like, the centrifugal divergent magnetism. Bismuth loves this, hates this. How many times did I have to spin this bismuth disc to get that through your head? Now you understand. Yes, this is extremely diamagnetic, but diamagnetism applies to this, not this. Here, yes. Here, no. Oi. Explanations are one thing, descriptions are another. Any fool can read a description. This is what you get in college and high school. Explanations are something wholly different. Explanation is what divides the fools from the wise. It divides true understanding from random information. Open your mind up. Learn to think. Learn to think logically. And things will be made clear to you. Now you understand the secret of this supra-diamagnetic object. It is as attracted to the magnet as another magnet is, only expresses it differently. All atoms at the inner atomic are dielectricity and magnetism. Dielectricity loves dielectricity, doesn't care whether the dielectricity is in this quote-unquote magnet or it's in this bismuth disc. Diamagnetism only refers to the centrifugal divergent magnetism. That is why it's called diamagnetic. Here is not centrifugal divergent magnetism. Here is centripetal convergent reintegration, access point to the dielectric inertial plane of high dielectric capacitance inside this neodymium iron boron, which, as we've shown here time and time again, incorrectly called the block wall, which is merely a pathetic description, not an explanation. That's the dielectric inertial plane. It is the horse that is driving the horse poop, shooting out here along the magnet, okay? Everybody's enamored by the horse poop shooting out of this object right here, okay? There's a bunch of horse poop shooting out right here. Oh my God, that's so fascinating. It pulls iron, does this, it does that. Well, that's right. Here's the horse right here. This is what's driving the magnet, quote unquote. Dielectricity. Magnetism is dielectricity in discharge. It is radiation. Radiation attracts nothing. That's right. There is no such thing as magnetic attraction or magnetic repulsion. Just don't tell anybody else or they'll think you're crazy. Logical, provable, sensible, reasonable, rational. Explains all observed phenomena. All, without exception. All phenomena. But the notion of quote-unquote magnetic attraction is as deeply ingrained in the human consciousness as the sun rising in the east, and that snow is cold and that ice is hard. Drilling the facts home to a bunch of brainwashed fools that have regurgitated the same nonsense for thousands and thousands of years is difficult. Thanks for watching. Now you understand.